Yo, yo, do you hear me? This is Section 5, 6 Inequalities and 2 Triangles, coming at you live from OHS High School. This is Mr. Lane. Your objective is right down there. Again, you can read through the Y. Your number 5, make sure you answer that in your notes, and always be looking for that secret word. Who knows what it's going to be this section and where it's going to come. So make sure you're paying attention. Get that first one to me, 2 points. Alright, we've got two major theorems on this one, and they're actually related to one another. The first one is the Hinge Theorem, which basically says if we have two sides of one triangle that are congruent to two sides of another triangle, and the included sides are not congruent, then the longer third side is across from the larger included angle. So this is based off of kind of a door hinge, or just any type of hinge, I guess. So let's do this for a second. Alright, so these two sides do not change lengths. So we can make a triangle that would come right from the endpoints of those two segments. And as we widen this one out, notice that that third side that we would draw in there would become larger. So if we have two sides that are congruent and the angle that is not congruent, then as we widen out that angle, the longer this third side's going to be. So I think I got a picture here labeling the two. The angles actually shouldn't be marked congruent in there. So I'll put two marks over here and just one mark over there. But anyways, whichever one's the larger angle, the side opposite from that is going to be the larger side. So this is saying if angle A is bigger than angle D, then BC would have to be longer than EF. Okay, and then the converse of that is going to go kind of the flip of that. It would be if two sides of one triangle are congruent to two sides of another triangle, and the third sides are not congruent, then the larger included angle is across from the larger side. Okay, so again, these two shouldn't be marked congruent. This says that this is larger than KL, or JH is longer than KL. So therefore, this angle J would have to be larger than angle M. So again, pretty closely related to one another. But that's our major concepts. Let's see how we can apply those in this lesson real quick. So we're supposed to compare, let's see, BAC, this angle right here, with DAC, so with this angle right here. So notice reflexive property tells us that AC is shared in the two triangles. These are marked 4, AD and AB are both marked 4. So we got to compare these sides opposite or across from the two angles that we're comparing. The 7 is bigger than the 6, so therefore we could say that the measure of angle BAC is going to be bigger than the measure of angle DAC. And that's the Hinge theorem. Alright, let's move on here. We're supposed to compare EF right here with FG. Again, I see that we have the reflexive property. I see that we have both 7 degrees, or sorry, 7 marked for lengths here, which make H a midpoint also. And then we've got a linear pair sitting right here. So if this is 82, 82 plus what equals 180? Well, I think that would be 98. Then for this angle. So we're supposed to compare the sides opposite of these two angles. And if the larger angle is 98, then that means that FG is going to be bigger than EF. Okay. Alright, so we're supposed to find the range of the values for K. So K is right here. Again, it looks like we have the sides marked congruent and reflexive property. And then we know that this angle is 38, and we're supposed to find what K could be. Looking across from the two angles that we're comparing, it looks like the 19 is going to be bigger than the 18. So that means that the 38 degrees is bigger than the 5k minus 12. Alright, so let's solve this real quick by adding the 12 to both sides. Looks like we'd get 50 is greater than 5k, so we'll have to divide by 5. So it looks like 10 is going to be greater than k. So k would have to be less than 10. And then we couldn't have a negative angle on here, so let's see, what would that be? 2 would still be negative. Let's find out what makes it 0 real quick. So let's just set 5k minus 12 equals 0. So let's see, it looks like 12 when we add it to that side. So 5k equals 12, divide by 5, divide by 5. So when k equals 12 fifths, it's going to be 0. So we can't have anything, we have to be above 0. So we're going to put k is bigger than 12 fifths. So that would be how we'd want to leave our answer on that one. Alright, regular geometry students would be doing these problems at this time. Good luck with those. We're going to move on in this iPad geometry class here. Let's see, we got John and Luke leaves the school at the same time. John rides his bike 3 blocks west and then 4 blocks north. Okay, Luke rides 4 blocks each and then 3 blocks at a bearing of north 10 degrees east. Who is further from the school? Explain. Okay, alright. Well, let's get us a little picture going on here. So I'm going to draw a little coordinate plane in here. Right here we'll say is a school. And we got John, which travels, let's see, west. Let's see, west. Never eat sour watermelon. So let's see, we should go west 1, 2, 3, and then north 1, 2, 3, 4. So right here is where John sits. Alright, and then let's see, on Luke, he goes 4 blocks each, and then 3 blocks. So let's see, 4 blocks, and then 4 blocks. Oh, that should probably be east, I'm guessing. Yeah, let's change that to east real quick. So 1, 2, 3, 4. So he rides to here, and then he goes north and to the east, a bearing of 10 degrees. Does it say how far? Then 3 blocks this way. Okay, so we're going to just estimate about what 3 blocks would be, right about there. So this is where Luke ends up. Okay. Alright, so which one is further away? Was that 4? Let's create a little triangle there. Alright, so in John's, it looks like, to compare his distance, this is going to be a 90-degree angle for his distance. For Luke's distance, when we draw in his distance here, well, it's 90 to go north, and we went another 10 degrees. So that looks like it's going to be maybe 110 degrees, which is larger than the 90 degrees. So it looks like Luke's distance is going to be greater than John's distance from the school. So let's move on. Regular geometry class would have 7:15 from 3:43. iPad class, yours will be at the end as usual. Alright, we got one last example here. It looks like a 2-column proof. I know you guys have missed proofs, so it looks like we're going to get back into them a little bit. So we have a little drawing right over here. We're given that AB is congruent to CD. That's marked in here. And also it looks like angle ABD is going to be bigger than angle CDB. So we're going to mark this one 2, and we'll just keep in mind that the 1 mark is bigger than the 2 marks in. As usual, we're probably going to start off with this given information. So let's copy and maybe paste it right here. Okay, how well that worked. And oops, I guess that's going to go right there. And then the word given. Copy and paste it real quick. And it will come right over here. Now we're started on our proof. And let's go to number 2. Well, notice that for the Hinge theorem, we're going to have 2 sides congruent, then the 2 included angles non-congruent. So it looks like we need another pair of sides congruent if we're going to use the Hinge theorem. So we're going to have to say that BD is congruent to BD. And hopefully you've learned this by now because we've had it 500 times, I believe. But when we're saying that something is, or the mirror image of itself is going to be the reflexive property. And you might slap in the word there, congruence also. Alright, and then we're to number 3. By the way, secret word for the video is large. Large is a secret word. Alright, now let's finish this on up. I think we're actually ready to go to what we're trying to prove. I think we got the Hinge theorem. This is bigger, so AD is going to be bigger than CB, and I think we're ready to state that. And of course our reason is going to be the Hinge theorem. So let's write that in here real quick. Nice and short proof, kind of like that. Makes it easy. Let's see if I can just copy and paste this right here. Bam. And we're good to go. So nice, easy, and short proof. Let's wrap this thing up. Right here's the regular geometry class problems to work. There's the up 1, down 1s. Good luck on those. Here's the boxes if you're watching from the regular geometry class. Good luck with that. Alright. So this is Mr. Lane signing off from OHS High School. Have a good day.